Okay, so brothers and their sisters, we are going to again restart, or you can say resume our signal generation and resampling course in a Matlab, which comes under the signal processing core skill development. So yesterday we have completed the 58% of the course already. Now we have to complete it to up to 100%. So let's start. First of all, there are some commands that I have to write, which is pre-spectrum, which used to see the spectrum of a signal if you are on the Matlab workspace. But if you are on a signal editor, then you just need to click on the spectrum option. Then you can see both the power spectrum, and also if you click on the frequency or time spectrum there, then you can see the time and frequency spectrum there. But for Matlab, you have to write the command to see the spectrum. Okay, so let's start the video.
When you sample a continuous time signal, you can try out different sample rates.
So basically, what is a sample rate? Sample rate is nothing but a discrete value which is known as n. So what is discrete signal? Discrete signal is nothing but it is a value of a signal at an instant of time. So you can see that we just have to move backwards here at this place. So you can see that at this point the value of sample rate is this. Sorry, the value of signal is this. At this point or at this time the value of signal is this. So you can see this points at different time is known as a sample rate.
You can try out different samples.
And it is only exist in the DC or discrete signal. A DC signal is completely different, but a discrete signal is also known as an analog signal because it has a different value of a property, or you can say yes, property at a different time.
Sample rates. But if you need to change the sample,
and see that the more time the more sample rate is there, the more clear signal we can see. And if the sample rate is very high, then we can get a proper continuous signal which is known as CD signal.
Sample rate of a signal that's already sampled, you could get unwanted frequency content. For instance, sometimes you're stuck with two devices that have different sample rates. Maybe your microphone records at 8 kHz, but your audio equipment has filters designed at 48 kHz.
So here the problem is that the input is of 8 kHz and output is of 48 kHz. So how can that 8 kHz signal get converted into 48 kHz signal? Here we have to use a sampling method which is known as upscaling, because when we use the upscaling method, what happened here is that the extra sample rates generated, like when the value at time x is equals to 0 at here, then my voice is echoing. Okay, so the value of the signal here, I have to make it, I guess, because it is easy to understand by visualization as compared to by just listening. So I am telling you that this is our continuous signal, okay, and of 8 kHz, and this is our signal of 48 kHz. Okay, so this is 48 kHz. So when we try to draw it in a discrete, what will we do? We will just make a lines like this. So this is our discrete signal of 8 kHz. So you can see that here, if I mention is at 1, 2, up to n. On this axis it goes up to n, okay, and the same signal for this, like 1 2. My drawing is not good, so please don't. So this is 8 kilohertz signal, which is nothing but the sample of rates are increases. So this is 1 2 and up to n is nothing but the number of samples. So how can we convert it? We will use a sampler. What it does, that at the value 1.5, here is nothing. So what it will consider in a 48 kilohertz signal, that at point it is 1, at point 1.5 it is 0, so this is 0. At point 2 it is 2, and at point 2.5 it is 0. So you can see a little, or you can say a very tiny sample, or a discrete sample is there. So like this we can convert 8 kilohertz signals to 48 kilohertz signals. Don't save it. Let's see if I'm
If
right
you
or
want to
wrong.
use the 48 kilohertz device, you need to change the sample rate of your recording first. You might be tempted just to insert zeros into the 8 kilohertz.
Yeah. So as you can see that my simple logic is exactly like that. That we have to increase the sample rate, which is known as upscaling, so we can get the 8 kilohertz signal in, we can give input to a sampler of 8 kilohertz, and we can get output of 48 kilohertz
signal. This is called upsampling. When you add zeros to your 8 kilohertz recording, you will see high frequency content appear. These copies of your tones are called images.
Okay.
Because your recording was sampled at 8 kilohertz, you know that you don't want these in the upsampled signal. To remove them, you can low-pass filter your upsampled signal.
So what is low pass filter? So yesterday we saw that what is the low pass filter? Sorry. Okay, yesterday we saw that a low pass filter used to remove high frequency while keeping the low frequency. So here you can see the high frequency that we don't need it, because it is nothing but an image of our original signal, which is of 8 kilohertz. So
the combination of upsampling then low-pass filtering is called interpolating.
Okay, so I have to write it. Interpolating. Interpolating is nothing but technique where first upsampling or upscaling is done, then that signal get passed through low pass filter. For example, 8 kilohertz signals get converted into 48 kilohertz signal. Sorry.
On the other hand, when you want to decrease your sample,
so here if we want to decrease our sample rates, like we have an input of 48 kilohertz but our output system supports 8 kilohertz signal, then we have to decrease the number of sample of rate, so the frequency also get decreases. So here we have to downsampling first. You can see here that there are images. So first we have to use the low pass filter, then we have to use the downsampling, and then we get the proper low frequency signal, or you can say low sample rate signal.
Rate, you're downsampling. In this case, you risk violating the sampling theorem and introducing aliased tones. To avoid this, decimating will low-pass filter
So alias tone, what it is? It is nothing but I have to again use the pen, because the signal and systems you cannot understand without drawing the signal. You have to draw first. So what is aliasing signals? You can say aliasing error. So you can see that these are the two signal I have. Okay, first is this, and sorry, not like this. This type of signal we need. So when we have to decrease the sample rate, what we do, we decrease the number of samples. Am I right? So what happens here, that if we decrease too much number of sample, then the signal get crossover on each other. So you can see here you can see that on these 2 points we get the lost signal, because it contains both this signal as well as this signal. So we get the loss of signal here, and this is known as aliasing. Okay, so to reduce this we have to use low pass filter.
for downsampling to remove frequency content above the new Nyquist frequency, greatly reducing the aliasing. Now, interpolating and decimating require integer factors. So how do you change the sample rate by a non-integer factor? Integer factors. Interpolating.
Okay, so this method is known as decimating. So decimating is a technique where first low pass filter passes the higher sample rate signal then the down sampling is done. For EX to convert 48 kilohertz to 8 kilohertz without losing any data.
And decimating require integer factors. So how do you change the sample rate by a non-integer factor? Well, you interpolate first and decimate second. Then the two low-pass filters can be combined. The resample function in Matlab can interpolate, decimate, or both with a...
So here, if you want to do both interpolating and decimating at the same time, then we have to use the resample function, where first the upscaling happened, then the low pass filter passed that signal to the desampler, and then desampling is done. And that's how we get what? I didn't understand that part, but we will see about that in our exercise. Low pass filter and downscaling. That's how my whole
single function call. In the next activity, you'll listen to a resampled signal with and without the low-pass filter and explore the effects on the resulting signal.
Okay. Next. How can I do the raise button here? say. Okay, so what does it says that f equals to 300 and 3000. So the frequency has a value 300 and 3000, and Nyquist, or you can say fs equals to 24,000. Now, in this activity, you will start with a signal with two tones, one at 300 Hz and the other at 3000 Hz. Okay, the signal is being properly sampled. The sample rate is well of 2f equals to 6000. Okay, then you will downsample the signal by a factor of 6. So the sampling rate of a downsampled signal will be fs equals to 400 sorry 4000 hertz, which will introduce analyzing. You can see what happened in a spectrum, and you can listen to the signal to hear the effect. Okay, so this is a fascinating thing for me, that I can hear the signal. I never thought that I can listen to a signal that I am making or doing a processing on a signal. So here the tone at 300 Hz is less than Nyquist frequency. Nyquist frequency is the best, you can say, theorem from where you can find the best sampling rate for your frequency. So it is still in a correct location. Okay, so let's start the course. What we have to do: downsample sign by the factor of 6. Name the result sign bad. So first of all, we need to create a downsample of a 6 signal, and then we have to store that signal in sigbad. So sigbad will be our variable. This is how you have to solve the sigbad task given in a coding program. So what we have to do, you can see the keyword to downsample any signal is downsample itself, and the x is nothing but your sample name, signal name, and n is your factor that by which you have to downsample this signal x. So we will use that same word downsample, where x is nothing but our signal and n is nothing but the downsampling factor that we have to return. So it is 6, and we have to name the result, then plot the spectrum with the new sample. For the spectrum purpose, we have to use this Control V, and let's see if it works or not. But we have to write here a bad. Let's see. I need one more paper, so I will be right back in a minute. Okay, so first I have to write all the commands that are necessary for showing the spectrum. To plot the sample of to plot the spectrum of a signal, use P spectrum signal name and fs. Fs is nothing but a value. So you can see here the problem we are getting is the value of fs is not perfect. So what we have to do, we have to write fs equals to fs by 6. Sorry, we have to just add here divide and 6. Let's see, will this work or not? Yes, it is perfect. And also I have to write the command for downscaling also, to down sample a signal, use variable name equals to down sample signal name, comma down sample factor in int. Obviously, let's go to the second task, where we have to sorry, low pass filter sig. The pass band frequency should be where the Nyquist frequency will be located after the downsampling unit as a sig flit. Okay, so we have to go here, then we have to write this, then we have to click equals to, then we have to use this, which is low pass, and control C, control V, and then we have to write sig. And for fs new should be what, I don't know. Let's go to the second task, which is then repeat your code from the first to downsample the sig flit and display the spectrum. So first we have to copy this, control C, then we have to enter and control V. Now we have to just FILT flit, and then again we have to write a sig flit or downsample. Wait, I don't know. FILT sig FILT flit. Let's see what error does we get. I think this, yes, the first line we get an error. So we have to see the hint. You should filter the signal at 2000 hertz. So I didn't understand that. That's why we have to use the solution 2000 hertz by so here we have to just write as 2000 hertz. So this is 2000 hertz, so we don't have to write by 2. Okay, let's see. Again you have to write the equation for low pass, to the signal use y equals to low pass x new no fs new by 2 comma fs. Okay, like that. Now next, and we completed our 62% of the course already. Now duplicate the sig. So this is very easy for me. Duplicate the 6 and name is as sigdect. It's nothing but signal detected. So we have to go to rename option, then we have to enter yes. Use the resampler process method to resampler this by the factor of this. Okay, we have to go here, we have to go here, we have to select the resampler like this, then we have to select the sample rate, which is nothing but 0.167, and we have to click on apply. Okay, warning, okay, so sample factor, yes, sometimes mistakes happen, so you have to know where the problem is, and then click accept all, close, and display this signal. Yep. Next, drag the downsampled signal into anti-analyzing filter. So where is anti-analyzing filter? This is our downsampled signal. So we have to do the downsample here. So you can see there is, okay, I don't think there is anything known as a downsample or anything like that. Let's see the solution, what we have to do here. Okay, sorry, don't need to see the solution because first we have to reset. Now what we have to do, we have to drag this, put it here. After that we have to find this, then we have to go to the sample rate, and we have to make it 4000. Yeah, display the signal. The spectrum is perfectly okay. We have to use the spectrum like this, which is known as power spectrum. Explore the signal, that signal to the workspace, sorry, export with signal, this signal. Next, what we have to do now, first we done the downscale sampling, now we have to do the upsample. So here we have to use again the same formula as the previous one, but we have to store it again in the singbat function equals to upsample. Then we have to write the signal name, which is nothing but a 6, comma, and the factor is fs into 6. fs into 6. We don't have to plot, then plot, okay, sorry, I did a big mistake and I will fix it. What we have to do, we have to write here is it right, PSPECTRU, yes, this one, and then we have to name it as sigbad, comma, fs into 6. Yup, that's the perfect command that we have to give here. Sometimes mom had a so to upscale the signal, use y equals to upscale signal name, comma, upscale factor in int. Now, sometimes what happens that I just read the half of the question and try to solve the full and try to give the full answer, which is already from the point where I wait a minute, what it say that low pass filter. Okay, so we have to again use the low pass function here like this. Okay, 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 okay. Control C, Control V. The name is sigbad equals to low pass, and Y name is also the sigbad. Sigbad 150 hertz, I guess. Oh shit, sigbad 1500. Again, we have to copy this signal. Display the spectrum. Okay, so we get one warning here. Okay, we don't have to write the sigbad, we have to write sig flit. Yes, I mean that. Again, we have to run this. Let's see the solution. Slick fed equals to, okay, so we use here the low, no, Control Z, yes, low pass, this, okay, into 6, we didn't write the into 6 function. That is perfect. Oof. So the 70% course is done. Now we just need to do the 20% because the last 10% from 90 to 100 is nothing but the feedback and the summary of our all course. Then duplicate the signal this. We have to click on duplicate. Then we have to rename that signal. Rename which is known as sig int. Second, yes, perfect. Use the resampler process. Yeah, we have to click here, then we have to go to the resampler, then we have to select the sample factor up to 6, then we have to click apply. Okay, done. Display the signal. Yep, it's perfectly done. Next, drag the upscale symbol which is signal, which is this thing, this one. Yes, after that, that is not there. Yes, after that we have to click, I have to click here, then I have to go to this frequency set up to 18,000 hertz. Okay, and then I have to display. Now set the sampler to this and display the compare spectrum. So for spectrum we have to go here and click on the spectrum. Yep, sig fed don't have to display the sig. Next we have to do export the this signal we have to export in a workspace. Export. After exporting, we will click on submit, and that's how our 75% of task is completed. Now only 25% is remaining, and I'm very happy that I use upscale the flute signal so that there are twice as many samples. So for upscale flute equals to what? Upscale. SCA only. Up sample. Okay, मैंने मेरी कॉपी में गलत लिखा है. Okay, up sample, and after that what we have to do, we have to write our signal name, which is nothing but flute, comma, it has to be twice but what is the frequency? I don't know that, so I have to find it. Signal in it. Okay, sorry, upscaling factor, I don't want to see the solution. Fs into 2, which has to be twice as they said. No, there's something that is not perfect. We have to see it again. Where did we go wrong? Up sample flute comma 2. Okay, so we don't have to write the fs here. We already have to. Oh shit. No, that's perfect. Let's see. Huh? Flute up. Okay, so I am taking a break of 10 minutes, then we will continue this course, okay? कितना है मेरे पास, शायद 30 है. ओके सो मेरा काम हो गया. लेट्स स्टार्ट. Save a new sample rate in a variable name. Save a new sample rate in a variable name f sub. No. Okay. डिस्प्ले नहीं किया. हाँ. अब क्या किया मैंने? Let's see the solution. What did we? Okay, fs into 2. fs into fs into 2. 2 तो पहले ही लिखा, 22 हो जाएगा. अब सही है. मेरे को थोड़ा थोड़ा आता है लेकिन मैं फिर भी भूल जाता हूँ. सॉरी, मेरे को इंग्लिश में बोलना था. Okay. So, create a flute up, but this time use the resampler function. तो resample function तो मैंने डाला नहीं था. resampler function हमको यहाँ पे मिला है. ठीक है. और इसको flute up equals to control v. अब यहाँ पे resampler function हमको मिल गया है. x रहेगा हमारा flute up, जो कि हमने डाला है कि नहीं. flute up where q and r are the integers sampler factor. तो उसकी वैल्यू क्या रखूंगा? हाँ, तो मेरे को भी पता है. ये लेना है और सेम चीज डालनी है. ओके. वही ना, QP की वैल्यू क्या है? अच्छा यहाँ पे दिया है, बिकॉज द इमेज नीड्स अ लो पास फिल्टर ऑफ 8 किलोहर्ट्ज. ओके. P by Q सैंपल्स, तो A की 4 by 2 let's see the solution. बिना उसके तुम कैसे बताओगे यार? हाँ, अच्छा रिसैम्पलर हमको ही यहाँ पे डालना था. सॉरी, गलती हो गई. कंट्रोल C. इसको डालना है टास्क 1 एंड कंट्रोल V, और इसको फिर काट देंगे हम. टास्क 4 है ना ये. ना, अब देखते हैं कि क्या डाला है. 2 और 1 डाला है यहाँ पे. ओके, 2 1 क्यों डाला मेरे को समझ में नहीं आ रहा. 2,1. तो मैं वीक सैम्पलर का नहीं लिखने वाला, क्यों, बहुत इजी है. अरे फिर देखना पड़ेगा यार क्या प्रॉब्लम हो रही है. फ्लूट था क्या? ओ फ्लूट है, मैंने यहाँ पे फ्लूट अप लिखा है. सॉरी. कंट्रोल जी. ठीक है, अब सही है. स्पेक्ट्रम एक ही बार करना है ना. यस. क्रिएट अ न्यू टाइम वेक्टर. मेरी ना इच्छा नहीं होती, लेकिन 75 पे तो कर लेता हूँ. क्रिएट अ न्यू टाइम वेक्टर कॉल्ड tub, which is nothing but a top cut that uses a new sample rate. Use it to create a sweep signal from this to this. Name it as create a new vector called मेरे को यार ये देखना पड़ेगा, क्योंकि मैंने क्रीप ये लिखा नहीं था. क्रीप बोलता शिप के मैंने लिखे नहीं थे यार. लिखना भी पड़ेगा मेरे को. टू सिग्नल use सॉरी है भाई. ये सब तो हमको, मेरे को पता ही नहीं ये सब कहाँ से आया. कॉपी पेस्ट ही करना पड़ेगा, क्योंकि ये पढ़ा ही नहीं है ना अभी तक. पढ़ा मतलब ऑब्वियसली पढ़ा है मैंने, ऐसा नहीं है, लेकिन मेरे को पता नहीं है कर हो क्या रहा है यहाँ पे. पढ़. लेट्स ट्राई टू अंडरस्टैंड what is going on here and what does this code says. Tub equals to 0. Okay, so it starts from 0 and okay, तो यहाँ पे हमने t की वैल्यू असाइन की है tub. ओके 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 ओके, तो t की वैल्यू यहाँ पे असाइन की गई थी. एड अ फ्लूइड एंड वाटर मार्क, और उसके बाद इसको डिस्प्ले भी करना है ना. तो स्पेक्ट्रम डिस्प्ले करने के लिए सबसे बेस्ट क्या फंक्शन है, यही है, कुछ नहीं है. परफेक्ट. तो ये जो सिग्नल आ रहा है ये वाटर मार्क है. ओके, सो अभी हम ऑडियो को लिसन करके देखते हैं यार. हाय साहब, सिग्नल लिसनिंग इज एट डिफरेंट लेवल. ये तो बहुत सही चीज है यार. let's see what we have to do. We have to write this to listen to a signal. Use sound signal name comma fs is sample rate. व्हाट इज मीन बाय एफएस? एक मिनट, मेरे को थोड़ा प्रॉब्लम हो जाता है, पता है क्या, फिर कभी कभी। व्हाट इज व्हाट इज मीन बाय एफएस? यहाँ पे सर्च करते, ठीक है। ये नाइक्विस्ट फ्रीक्वेंसी होती है क्या, पता नहीं। सैम्पलिंग फ्रीक्वेंसी होती है ये, ओके। मैं वही तो बोला, सैम्पलिंग फ्रीक्वेंसी। So it is nothing but a sampling frequency. Next, we can go to the next task and you can say 79% course is completed. 24 हो रहा है यार, मेरे को शायद जाना पड़ेगा, ठीक है। मैं 40 तक करता हूँ, फिर मैं चले जाऊँगा, ठीक है। Import the audio file this into a variable name bird. ये शायद देखा था मैंने यहाँ पे, कहीं पे तो देखा था यार ये। हाँ, ये देखा था मैंने। To import the signal data from files text birds equals to read matrix, audio read matrix, yes। स्पेलिंग सही है क्या? रीड मैट्रिक्स, और ये हमारा फाइल का नाम है जो कि है mp3। ठीक है, इसके बाद एफ एस बी इक्वल्स टू क्या रहेगा मेरे को पता नहीं। स्पेक्ट्रम ना, तो स्पेक्ट्रम के लिए ये वाला लगता है। नहीं नहीं नहीं, लेट्स सी द सॉल्यूशन, क्योंकि जब नहीं समझ में आए ऑडियो रीड ही आएगा यहाँ पे, ठीक है। यहाँ पे आएगी हमारी मैट्रिक्स दिस दिस एफ एस बी, इसमें कॉमा, ओके। बाकी तो सही था मेरा। अरे यार, ऑडियो रीड बोला तो था वहाँ पे। ये भी लिखना पड़ेगा। हैं? मॉडिफाई। तो मैं बोलता हूँ आज के लिए इतना ही रुकते, क्योंकि अब मेरे को कॉलेज जाना है, तो आज के लिए इतना ही कर देता हूँ मैं ज़्यादा अभी आगे बढ़ता नहीं हूँ। ठीक है, तब तक के लिए बाय। अपन करेंगे इसको नेक्स्ट